So this is a Millermatic 252, and it doesn't recognize the gun. And some of you may say, well, let's start with the easiest stuff first, because that's a great idea. And it's the best way to do it. So the most common failure of that is a bad trigger. If you take your gun leads and take a continuity reading across this, you should have continuity when you depress the trigger, meaning that when you pull the trigger, you should hear that sound. The beep saying it's good. And that is exactly what we have. So the problem then lies between the connections here and the actual machine itself. So what I'm going to do is haul off the cover here and start to investigate where that might end up. Okay, so for this next test, to definitively prove that it is not the gun, we are going to quite literally jump the gun. So going across the two terminals here at the bottom, this will take it out of circuit. And if we turn it on and can't do a reset, we know 100% for certain it is not the gun. I'm going to put this in and we'll give it a go. All right, let's check it out. So we've energized, and we cannot go lower. So, it still doesn't recognize the gun. And since there's no gun, we know for certain now that the problem is in the brains. So right away, we're gonna take the cover off. There, all these fasteners on the outside, you can see some there. You just pull that off to access the inside. If you're watching this and you have a Miller 252, odds are you know exactly where we're going. But for those that are just starting that somehow have one of these, maybe this will help you out. In addition to the 3/8 fasteners on the outside, you got to get rid of these ones here too. So that's a simple pull out, and let's all keep them together now. All right, with that off, there comes your top piece. Now we just got to finish the other side. All right, and with the last two fasteners, now we have this panel, which is free to remove. We could expose the juicy insides. Okay, so inside the 252, you got all this nice setup, nice and clean. These two wires, or that cluster of wires, the bottom set here is where the prongs come in from the gun and start meshing with everything here. And so now we come up to this sort of top control board that's coming into this control board. And all this is coming out of the control board. So the process is to go through and diagnose where the signal stops. And to help us with that, in a sense, we don't get the full circuit map layout here, but you do get this overview of where everything goes. Okay, now this section is if you have, I think it's a 9-pin, 1, 2, 3, 4, 5, 6, 7, 8, whatever, close to it, more than 2. This section there in the middle of the screen is for your spool grunt, and we are going to follow this. So RC31, wire 40, RC32, 19, goes to trigger 1, trigger 2 primary. So we can test that. We're going to check continuity off those sensors, and we'll check the board up here, but that's the next step. So to get this board out, looks like all we need to do is remove that fastener, because it looks like it slides into a pocket back here. We'll have to get it on some side. We might have to reach in and remove that clamp that you can see at the top of the board there. And then we'll remove this. So that should be pretty easy to do. All right, it was wrong. You can get to it from this side. So we got a fastener out front, and then we got 2 of the fasteners here, so that'll make it easier. I'm using a 7/32 wrench to get that out. So that means it doesn't fit perfectly, which means it's probably metric, even though this is from the States, which makes sense. It's sold internationally. So yeah, do that and get a... All right, so these two are 8 mil. So it is metric fasteners. There's the 8mm on it. So 2 here, and then 1 on the front. Okay, with those off, and then you can just pull these knobs off. And so given how the slots are in, like you can't mess up the position putting them back. So with the 2 top clips off, you can now extract the board. Time to look for some let the smoke out marks. Well, nothing stands out here. Everything looks nice and all the potting is still good. So I doubt it's this. But then that also looks nice, and there's definitely something wrong. Okay, I'm going to pop off and just make sure that the connections from the gun input are good. So the wires that are coming to the board from the gun input are good. So I believe that is the top clip, the one with 4 pins. Okay, so following the 2 lines back to our 4-pin input, got the 2 lines marked. Now we should get continuity across these because the jumper's back in. If we do, we know that there's no problem with the lines. So I'm going to need 2 hands. Okay, here we go. Continuity, it's not the problem in the lines. Okay, the board's back in, so I'm going to reconnect the elements that I took off, and then we'll focus our attention back here. All right, with the front main board there, or it's not really a main board, front motherboard, or whatever you want to call it, put back. Now we're going to study the pinouts here. So from the gun, they go into the positions 1 and 2 on that board. So it's time to pull this whole board off. So what I see is we have the same kind of clips up front. We would almost certainly have some sort of fastener somewhere, but maybe we don't. I don't know. Seems like it would be a rather large component of the absolute essence of this welder, so I don't know. But time to get back into it. Okay, here's the board off. Now to see if there's any obvious signs of smoke. Nothing. Or at least nothing on first inspection. So now it's time to trace. Okay, so the top 2 here and here, this one and this one, are the incoming from the gun. If I measure or take an ohmage reading across the resistors, we're going to get an equivalent resistance across the whole circuit. So that's not necessarily the way I want to go. I think visually we can look at it and determine that there really isn't an issue here. The next thing that I think these lines come to, if I can kind of sort of make it out underneath, is that we have an Optocoupler OC2 and an Optocoupler OC1. Inside of these there's a light emitting diode, and it's essentially a transfer of information to protect the rest of the circuit, which is of course black magic. Anyway, so pin 1 and pin 2 should be the forward voltage for the diode on both of these. I found the schematic for it. So I am going to use the multimeter to test the diode forward voltage. So I'm going to switch it over and see if I can get a shot doing that. All right, I'm going to go ahead and test those couplers. So we'll move it to diode. So it matters which way you do this. In this case, what we're doing is using the red. So is our forward voltage, so positive to negative. I'm going to have to put this underneath my chin to do it, but here we go. OC1. 1.5058. OC2. Uh-oh. May need to oversee itself off my board. So 1.058 and then an open circuit, or not an open circuit, excuse me, it's a short. All right, since we know that one's messed up, there's no point in keeping it all nice, make it easy for myself, just cut those and remove the solder and the tips from the other side. Won't be able to film this, it's going to be too complicated. All right, I had to break out the heat gun for this because with this ultra tiny tip, I just can't keep enough heat in to push this through. This stubborn pin has been hours of work to get this out. So we're almost there. Okay, now it's time to put the replacement part in. So I'm just going to plunk it in there. I think we'll have enough. I've got to match the pin out orientation, so it's got to go like this. Okay, then I got to do the other side, and then I'm going to have to be creative with how I solder that. Okay, we got the new part back in the board. Tested, diode check went fine. It was close to the other one that's in situ actually. So time to solder it back up. All right, there are the pins, the ground pin there, which took all the heat. Originally, you could probably use a little bit more work, but I did a pretty good job there. Okay, moment of truth. Squints! Come on. Damn it. Fuck. All right. So plugs in, it's not doing anything. Or the gun is in. But if I take my multimeter and I short out the pins on the receiving half of the signal on this side, it will advance. Watch. See the gear? Now, if I do this to the other side, it makes the wire feed rate go way high. Okay, so doing this test procedure now to track down that 35 volts, I'm going from RC3 to 5. So 8.1 here, and I should see 35 volts DC, which I do. So that's a pass. Next step is RC31 to RC32. Okay, so RC31 to 2 is right there. And we should have, this is for the Mig Gun trigger. This should also be 35. And we have 0. So we have a problem from the power transfer somewhere on this board, wherever it goes in from the power in, which is that series of lines there, the yellow and black, that's out of focus, to getting over here, which is now also out of focus. All right, so here are the results. We've got a pass coming into the board, and then we have no voltage whatsoever across V9. So maybe we have a broken DC rail somewhere on that board. Now I have to hunt down who goes where and what goes in the who now. So I got up after thinking about this a little bit more, and I realized, you know, maybe I can't see it just because I'm not using a powerful enough light. Now I should be able to find the traces, figure out where I have to go to next. All right, so I've had more and more infrared shots, and I'll see if I can include them here. And all I can really see is that we have marginally warm resistors near the transistors. So here, And there's a couple up here. I don't know if those are just feeding into that microcontroller at the top. Either way, I don't think that those are a problem. I've tested this one down here, which is R62, and really, like, there's only really one failure mode for resistors, and you'd see it. They do the crack, let the smoke out or whatever. I have never really found a resistor that has been out of spec that hasn't shown signs of visual failure. So my plan now, assuming it is part of this 40-pin Atomega 16, is to actually supply the board with 35 volts from these two pins, and then take a picture of it. Maybe then, even with some small current, I'll be able to see what components of that particular circuit are being activated. Now, because I don't have anything to fit in there, what I did is I cut half of these kind of connectors off and rolled them over so they'll be able to fit RC1 and RC2, or RC31, RC32. So I'm going to make some wires for that, and then we're going to set it up. We're close. It's 35 volts is what it's supposed to get. I've tested that there. So now, let's see if anything sticks out. Okay, same as last time. Nada. Nothing at all. Maybe what I'm doing isn't actually physical. Here's my little jumper I got from my kids' circuit set. Going into pin 5, which is right there in the middle. Continuity tested just fine. So I'll plug that in and redo all my tests. All right, just for good measure, I redid the wiring. So I have those little connectors spliced into the back, so to speak. Jammed in with electrical tape is a better way to put it. And still no change. And for good measure with the setup, checking across those two resistors coming out of the RC3, RC1, we have our 30.72 volts. No dice. Still not willing to give up yet. But if you've come this far, you're probably leaning the same direction I am in that. Microcontrollers, which of course you can buy off the shelf for parts, but it's how the pins interact with each other, which is, I think it's like kilobytes of memory or something. They're programmed, so that is what you're paying for. So this is the voltage for the spool gun. So maybe we can hotwire it. All right, for this Hail Mary, so to speak, having a lot of those recently, to try to put this machine into reset mode, because maybe that'll clear whatever's happening, is that we have to start the machine with the trigger depressed, so on the Mig Gun. But we'll do the same thing with the spool gun, because we know we have our active 35. So I'm going to put these together, energize, and spin these. Please don't explode. All right, so I had the procedure wrong, and I looked in the manual and I found this very small word that was in there telling you the actual order. So to do the reset correctly, you have to short. So even this will work even if you have a spool gun. So trigger is depressed, that's what that is. You turn this on now. Okay. Over 1 to reset off. Now disconnect. Now turn it over to on. Reconnect. And now it's been reset. Okay. Now let's see if that works. All right. 19 volts, 320, so the reset definitely has happened because it was at 14. Come on, let's hear something. Nothing. Nothing at all. Okay, let's test the voltage coming out of RC1 and RC2. So, although the resistors didn't look burnt or anything like that, I have decided that it's time to now go resistor by resistor. And let's do the old test here, because this is interesting. So I should have a 4.7-ish ohm resistor kicking around, unless it fell to the ground. It'll be around here somewhere. I'll just show you what the fluke is reading on that. I've measured the resistance of those two leads. We're not touching anywhere. And so those are about 0.1. That's what I'm getting anyway. And so, well, including the machine, we're right on target for 4.7. Now, let's do the same thing, but with that resistor. Same thing. So this is resistor number 36, and we have an open lead. And that sort of spot you see there is actually where the conformal coating pulled off the outside. So it would appear we have at least one bad resistor. I've already checked the capacitor, number 31, and that is correct. So if this is the problem, then the circuit mapping should also say that we have a problem with R62 or R36. I'm going to try to find a 1000.2 ohm resistor, I guess. Okay.
So RC, or the RC1, RC2 connections here, I had a resistor that was 10 times what it should have been. And then the big resistor over there, there was an open lead. So this is what I have right now. And here we go, test-wise. Okay. Come on. No way. I think I got it. Sick.
Okay, with that out of the way, I'm going to actually try to get that stuff out of the hole there. It really needs to go all the way through, and the way I had it on, just sort of sitting there for the test, did its job, but it wouldn't even withstand a slight breeze. So moving the machine around, it would definitely fall out. So I have to do that properly. And yep, so here we go. I might even upgrade that to the larger power, just because these lines here are certainly not as thick as the ones that came with it. So I don't want to have to do this again. So that's probably what I'm going to do. Okay, so there are the replaced resistors. Capacitor C31 again was okay. So this one here is a 1000 ohm, and this is a 1.21 thousand ohm. So I've checked continuity again, and what I'm going to do, since these are kind of off the board and blah, is I'm going to put some hot glue on the ends here, just to make sure that they don't touch anything. And I did go ahead and upgrade this resistor to a larger power one, because I'm really not certain of the quality of the other resistors that I had kicking around. So once that's done, I'm going to put everything back, retest it, and then comes the actual welding tests. All right, so the two larger resistors are there. So let's see what happens. Help 003.